Hello and welcome back. This is the metabolism series, and today we're going to talk about the nucleotide synthesis. If you know, nucleotides are based on purines and pyrimidines. In this video, we're going to discuss both, and on the next video, we're going to talk about the degradation. So let's begin. Okay, so here we are in the cytoplasm. This is the pyrimidine synthesis. We will start with glutamine, and together with bicarbonate, they're going to combine and create carbamyl phosphate. Okay, this is the metabolite we used in the urea cycle, and this is the exact same enzyme we used, but as I told you, this is the type 2, which is in the cytoplasm, the carbamyl phosphate synthetase. We're going to need water and 2 of ATP. Carbamyl phosphate is going to get converted into carbamyl aspartate using aspartate. And the enzyme is the aspartate transcarbamylase. Carbamyl aspartate gets converted into orotate using the dehydratase, and water is released. And then the orotate, we're going to bind it to the phosphoribosyl pyrophosphate. Okay, so this molecule comes from the ribose 5-phosphate. Do you remember this metabolite of the pentose phosphate pathway? Okay, so ribose 5-phosphate with the use of the ribose phosphate pyrophosphokinases using ATP will create the phosphoribosyl pyrophosphate. This molecule is going to bind to the orotate, and we will get the orethidine monophosphate using the orotate phosphoribosyl transferase. To recap, we are going to form this structure. With the use of the aspartate, we will get this path from carbon number 1 to carbon number 4 going this way. This nitrogen right here is coming from the glutamine, and this carbon right here is coming from the CO2. Okay, so we were left with the orethidine monophosphate. We use the UMP synthase to create UMP. UMP can be used for creation of RNA, but we need UMP to synthesize the other pyrimidines. So if we go this way first, with the nucleoside D-phosphate kinase, we're going to use a pyrophosphate and add it to the UMP to create UTP. We just added 2 phosphates, so from UMP to UTP. And then using glutamine, we're going to convert the UTP to the CTP. And then CTP to CMP. We are going to get rid of the phosphates we added before. And CMP, cysteine monophosphate, is going to be used for the RNA synthesis. If we continue, we have an important enzyme in this step, the ribonucleotide reductase. And I am going to explain it right now. This is the ribonucleotide reductase. This enzyme has 3 sites. 2 of them are allosteric sites. They are meant for regulation. And 1 is the active site, where we convert the ribosyl nucleotide to the deoxyribosyl nucleotide. So we have here the ATP is going to activate this enzyme, and the deoxy ATP, the DATP, is going to inactivate this enzyme. This is an allosteric regulation, the activity site. And then we have the substrate specificity site. If we have the DATP and the ATP, those have an A, they're going to stimulate the conversion to the deoxy form of the CDP and the UDP. If we have in this specificity site the DGTP, the deoxy-guanine triphosphate, we're going to stimulate the conversion of ADP to the deoxy form. And then if we have the DTTP, we are going to stimulate the conversion of the GDP into its deoxy form. So, having that in mind, if we come back here, we will see that we are going to need a phosphate. So from CMP with a phosphate, what we get normally? A CDP. Okay, but with this enzyme, we're going to get the deoxy CDP. And then the deoxy CDP will eventually lose that phosphate again and create the deoxy CMP. And this is going to be used for DNA synthesis. On the other hand, we have directly this enzyme, the ribonucleotide reductase. So again, we're going to add a phosphate. And normally when we add a phosphate to the UMP, we get what? UDP. But with this enzyme, we get deoxy UDP. That will lose a phosphate and it will create the DUMP. And then what? A tetrahydrofolate is going to act on that and is going to give a carbon group to this molecule, creating the deoxy TMP using the thymidylate synthase. And then this molecule is used for DNA synthesis. If we go to the purine synthesis, well, we have many ingredients, if we can say that here. We start with the phosphoribosyl pyrophosphate, the same molecule we synthesized from ribose 5-phosphate from the pentose phosphate pathway, if you remember. We're going to add a glutamine to it and then a glycine. Then tetrahydrofolate is going to give us another carbon and then another glutamine, as you can see from the numbers. And then the bicarbonate is going to give us another carbon and the aspartate, the last amine group, the last nitrogen. In the pyrimidines, we create the ring and then we add it to the ribose. In this case, we're going to build this structure upon the ribose. So as I said, we started with glutamine and nitrogen from glutamine. Glycine is going to give us this part here, these two carbons and this nitrogen. And then the tetrahydrofolate is going to give us this carbon here. And then the glutamine again is going to give us this nitrogen here. The bicarbonate is going to give us this carbon up here. And then the aspartate is going to give us the nitrogen here. And finally the tetrahydrofolate, again, the carbon right here. So this is the formation in 10 steps of the UMP inosine monophosphate. And then from this molecule we will use an inosine monophosphate dehydrogenase, dehydrogenase NAD positive to NADH, and we will create the epoxanthine monophosphate. That, with the use of a GMP synthase, is going to synthesize, guess what, GMP, using glutamine. GMP can be used for RNA synthesis. And then if we want the DNA synthesis, we're going to create the GMP, deoxy GMP, using what? Ribonucleotide reductase again. We're going to add a phosphate and create the deoxy GDP. We will lose that phosphate and deoxy GMP is created for DNA synthesis. On the other hand, we have the adenylosuccinate synthase using aspartate. Adenylosuccinate is created. Adenylosuccinate lyase will be used for creating AMP and fumarate is released. AMP is going to be used for RNA synthesis, and then if we use a ribonucleotide, we will add a phosphate and deoxy ADP is created. We will lose a phosphate and deoxy AMP is created for DNA synthesis. Okay, so that was it for the nucleotide synthesis. and in the next video I'm going to discuss its degradation. I hope you liked the video. Click the like button if you did, subscribe to the channel, and I see you on the next one.